Dark matter isn't just a fancy term scientists use to sound cool. Its existence was proposed when astronomers like the brilliant Fritz Zwicky noticed something peculiar. When they observed galaxies, the stars at the edges were moving just as fast as those near the center. According to the laws of physics, this shouldn't be the case. The stars at the edges should move slower. The only explanation? There must be some unseen matter exerting gravitational force, causing the stars to move faster. So, if dark matter is invisible, how do we know it's there? Well, it's like feeling the wind. You can't see it, but you can see its effects. Dark matter doesn't interact with light, making it invisible, but it does have mass, and mass means gravity. So, by observing the gravitational effects on visible matter, scientists can map out where dark matter is and how much of it there is. Now, you might be thinking, why does dark matter matter? Well, it's like the unseen framework of a building. Without it, the universe as we know it would simply fall apart. Dark matter influences the movement of galaxies, keeps them from spinning themselves into oblivion. It's also an essential player in the grand cosmic ballet of the universe's expansion. Despite decades of research, dark matter remains an enigma. It's like a cosmic game of hide-and-seek with scientists on a relentless pursuit to uncover its secrets. From the depths of underground labs to the vast expanse of space, the quest to understand dark matter continues. Though invisible, dark matter holds the universe together, a silent hero in our cosmic narrative. Even though we can't see it, touch it, or hold it, its influence is undeniable, shaping the universe in ways we're just beginning to understand. How fast do you think is the fastest thing in the universe? It's an intriguing question, isn't it? The answer may surprise you. It's not a spaceship or a rogue comet, but something far more ubiquitous: light. Yes, light. That familiar beacon in the dark holds the title for the universe's speed champion, traveling at a mind-boggling speed of nearly 300,000 kilometers per second. This isn't just a random fact, but a fundamental principle of our universe, often referred to as the cosmic speed limit. But why is there a cosmic speed limit, you might wonder? Well, it all comes down to a man you might have heard of, Albert Einstein, and his revolutionary theory of relativity. This groundbreaking theory, introduced in the early 20th century, fundamentally changed our understanding of time and space. Einstein proposed that the speed of light in a vacuum remains constant, no matter how fast you yourself might be moving. This means that if you were in a ship traveling at half the speed of light, and you shone a flashlight ahead, the light wouldn't move at 1.5 times the speed of light. No, it would still be moving at the speed of light. This seemingly bizarre concept is a cornerstone of Einstein's theory. But there's more. Einstein's theory also implies that as objects accelerate towards the speed of light, time slows down for them. This is the fascinating phenomenon known as time dilation. So, if you were able to travel at light speed, time would essentially stop for you. And there's another twist. The theory of relativity also tells us that the faster we move through space, the slower we move through time. This interplay between time and space, governed by the speed of light, creates a universe where time and space are interconnected in ways we're only beginning to understand. In a universe where nothing can outpace light, time and space weave a fascinating dance. So next time you flick on a light switch, remember you're interacting with the fastest thing in the universe and a key player in the cosmic ballet of time and space. Does the thought of an ever-expanding universe intrigue you? A key player in this cosmic drama is dark energy, a mysterious entity that's believed to be accelerating the universe's expansion. Dark energy, in essence, is a type of energy hypothesized to pervade all of space, acting against the pull of gravity and causing the universe to expand at an accelerating rate. It's a bit like blowing up a balloon, but instead of your breath, it's dark energy that's driving the expansion. Despite being invisible to us, scientists estimate that about 70% of the universe is made up of this elusive dark energy. Now you might ask, what's the big deal about an expanding universe? Well, it's not just about the universe getting bigger, it's about how fast it's getting bigger. The discovery that the rate of expansion is speeding up was so astounding it earned the 2011 Nobel Prize in Physics. But here's where things get really interesting. The accelerated expansion of the universe presents the cosmological constant problem. This is a discrepancy between the theoretical and observed values of the universe's expansion rate, a problem that has bedeviled scientists for decades. But what does this mean for the fate of the universe? Enter the Big Rip theory. According to this hypothesis, if dark energy continues to increase, it could eventually overcome all gravitational forces. Galaxies, stars, planets, even atoms could be torn apart. Imagine a universe where everything is ripped to shreds, a rather unsettling thought, isn't it? However, it's important to remember that these are theories based on our current understanding and observations. The universe, as we've seen, has a way of surprising us. So we are left with the puzzle of dark energy. It's the phantom force, the unseen actor on the cosmic stage, driving the universe's expansion. Dark energy, the mysterious force, drives the universe's expansion, taking us into an uncertain future. Imagine a place where time stops and space vanishes. Welcome to the world of black holes. In the cosmic chessboard, black holes are the enigmatic queens, feared yet fascinating. Born from the fiery demise of massive stars, black holes are the endpoint of matter's journey. When a star, at least 3 times the mass of our sun, exhausts its nuclear fuel, it implodes under its own gravity, creating a black hole. A point in space where gravity is so strong, it sucks in everything, even light. Now, if you're picturing a cosmic vacuum cleaner, let's adjust that image slightly. Black holes are not just 2-dimensional holes, but 3-dimensional voids. Think of them as spheres of darkness, a space where space itself ceases to exist. At the edge of this sphere, we find the event horizon, the point of no return. Cross this boundary, and you are forever lost to the black hole's insatiable appetite. It's a journey one way, a cosmic roach motel where everything checks in, but nothing checks out. Deep within this event horizon, at the very heart of a black hole, lies the singularity, a point of infinite density and zero volume. Here, the laws of physics as we know them break down. Time and space become intertwined and indistinguishable. It's like attempting to divide by zero on a cosmic scale, a mathematical anomaly that defies our understanding. Some even speculate that black holes could be gateways to other universes, wormholes traversing the fabric of space-time. But this remains purely hypothetical, a product of mathematical equations and vivid imaginations. And so, black holes remain shrouded in mystery, their secrets locked away behind the impenetrable barrier of the event horizon. They are the ultimate cosmic paradox, objects that are not objects at all, but regions of distorted space-time. They are the universe's way of playing hide and seek with us, showing us that there is more to reality than meets the eye. Black holes, the universe's most mysterious objects, continue to challenge our understanding of the very nature of reality. Is our universe alone, or could there be other universes out there? Let's step into the realm of the multiverse theory, a concept that pushes the boundaries of our understanding and imagination. This theory posits that our universe might be just one of a possibly infinite number of universes, each with its own laws of physics, dimensions, and even versions of reality. Imagine a cosmic quilt, each patch representing a different universe. Some patches might be similar to ours, with galaxies, stars, and planets. Others might be completely alien, featuring elements and laws of physics that defy our current understanding. But how does this theory impact our understanding of reality? Well, if the multiverse theory holds, it could redefine our perspective of existence itself. The notion of other universes could mean that our reality is not the only one. It suggests that there could be other realities running in parallel to ours, where different versions of us are leading entirely different lives. Now, let's consider our place in the cosmos through this lens. If we're part of a multiverse, our universe, with its billions of galaxies and countless stars, might just be a tiny bubble in an endless cosmic ocean. It's a humbling thought, isn't it? However, it's crucial to remember that the multiverse theory is just that, a theory. Despite its tantalizing implications, it remains an unproven concept. It's a challenging proposition to test because these potential other universes are, by definition, unreachable by our current means. But the beauty of science lies in its continuous quest for knowledge. Theories like the multiverse push the boundaries of our understanding and inspire scientists to devise new experiments, technologies, and ways of thinking. In the grand theater of existence, our universe might just be one stage among many. Are we alone in the universe, or is there life beyond Earth? This question has been a source of fascination and speculation throughout human history. But today, we're not just dreaming about it. We're actively searching for answers. The first thing to consider in this quest is the conditions necessary for life as we know it to exist. Life, as we understand it, requires a few fundamental ingredients. It needs a source of energy like a star to fuel its processes. It needs water, that universal solvent where biochemical reactions take place. And it needs a stable environment to develop and evolve over billions of years, like a planet with a protective atmosphere. But even if these conditions are met, it doesn't guarantee that life will form. This brings us to the Fermi paradox. Named after physicist Enrico Fermi, the paradox questions why we haven't detected signs of extraterrestrial life given the high probability conditions for life exist in the universe. If there are a multitude of planets that could potentially harbor life, where are all the aliens? One tool used to estimate the number of advanced civilizations in our galaxy is the Drake equation. Developed by astronomer Frank Drake in the early 1960s, it factors in variables like the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, and the lifespan of such civilizations. Yet despite our best efforts and calculations, we have yet to make contact. Is it because life is extremely rare and we are indeed alone? Or is it because our methods of searching are not yet sophisticated enough? Or perhaps life in the universe takes forms we can't even begin to imagine? The question of life beyond Earth remains one of the greatest unsolved mysteries of our time. As we gaze upon the cosmos, we are but stardust looking back at itself. We've traversed the grand mysteries of the universe together, and what a journey it has been. We've dipped our toes into the enigma of dark matter, that invisible, elusive substance that holds the galaxies together. A cosmic glue, if you will, making up about 25% of the universe, yet remaining unseen and largely unknown. We've explored the cosmic speed limit, the speed of light, a staggering 676 million miles per hour, a limit that seems to be set in stone, a boundary that even time itself respects. Then there was the puzzle of dark energy, the mysterious force that pushes galaxies apart, accelerating the expansion of the universe. This unseen energy forms about 70% of the universe, yet its nature remains largely a mystery. We ventured into the enigma of black holes, regions of space where gravity is so strong that nothing, not even light, can escape their clutches. They are the universe's ultimate secret keepers, hiding their information behind event horizons. The mystery of multiverses, the idea that our universe may not be alone, but one of many, each with its own laws of physics, was another fascinating concept we delved into. Finally, we pondered upon the enigma of life in the universe. Are we alone? Or is there someone else out there, gazing at the stars, just like us, wondering the same thing? The universe is vast, filled with mysteries that continue to baffle us. But it's these mysteries that drive us, that keep us looking up at the stars, that keep us wondering and questioning. They keep us humble, reminding us that we are but a small part of a much larger, grander cosmic story. As we continue to unravel the universe's mysteries, always remember, we are a part of this grand cosmic story.